UDS. So what is UDS? UDS stands for Unified Diagnostic Services. ISO 14229 is a universal, and you will be getting from internet also. You can go through all services. Many services it will support, which helpful for diagnostic purpose in current uh, situation. Standard protocol for vehicle diagnostics is a standard protocol. It's a common. Whatever OEM it will be there, it's applicable. It's a universal standard and used for communication between the diagnostic tools and the ECUs. As previously discussed, it's the main diagnostics happen between the tester tool and ECU. So this UDS used for communication between the diagnostic tools and ECUs. And main thing we have is a communication type. How we can communicate to ECUs. There are two different types of communications. One is a physical addressing, where we used to call as point-to-point communication. The tester tool directly connected to the ECU. The particular ECU, the one physical channel will be established. From that, we continuously uh, send the request to the server and receive the response from the server. This continuous communication will happen with the dedicated channel. That is the physical addressing. And one more is their functional addressing. So with one tester tool, many ECs are connected, and it will communication will be like in broadcast. How can will work in broadcast message oriented, right? That like that functional addressing will happen. We'll send and communicate through a functional addresses, and each different only one functional address will be there for request. In response, a different functional addressing for each different ECUs will be there. So physical addressing. So uh, as I told, point-to-point communication. The tester here, left side we have a tester. This is a tester, and this is a server. So tester will used to call as client, and ECU will call as server. So that is why this is a client-server communication. So I want to know some information from the server. I need to send a request to the server. That is in physical request, CAN ID 7E0. 7E0 particularly related to powertrain system, and the underlying protocol is a CAN. And in turn, it will send a response to us with CAN ID 7E8. That is again a response ID or CAN ID for powertrain. So I need to send a request, and ECU process and checks and a response back. This is point-to-point communication. And in point to multi-point communication, only one tester will be there. We have a CAN ID 7DF for a functional address, and multiple servers will be connected. And each server, if you see physical response CAN IDs, these are the different CAN IDs 7E0, 7E1, 7E2. So different ECUs will get a different response. Now we'll see the request format. So we need to establish communication that may be from physical addressing. So once channel is established, we need to communicate. How we can communicate? What will be the request format? In what way I need to send a request, and in what way I need to receive the response. That it is will get from the ISO 14229 standard. So it has some set of rules. We need to send a request in this format only. If you see in slide, I want to send a request. For example, if you see, I want to send a request for resetting the microcontroller. So if I want to resetting the microcontroller, he should understand the language. So what specific task I need to do. So for that, ECU reset is one of the UDS services. As I told, many services are there. In that, one of the services is a ECU reset. So it's only used for resetting the microcontroller. So if I select the moment, if I select reset service 11 here, it will understand. Server will understand. Oh, it is for only resetting thing. Okay, it is only tester requesting the something for reset, and it has a followed by sub function or parameter. Sub function is what in turn you have to do. Reset is okay. What type of reset you have to do? Some set of functions will be there. To get a specific task done, we need to mention the subfunction. Suppose, for example, ECU reset service 11, it will support hard reset, that is subfunction 01, soft reset, subfunction 03. I want to do, I want to perform subfunction 03 soft reset. In subfunction parameter, I need to 03. 11 03. If I send, tester will it will understand, okay, I need to perform the reset option. In that soft reset we need to perform. And the parameter is optional. Some services will support a parameter, some services will not support a parameter. It's optional. For example, here if you see, uh, uh, for example, if I want to turn on the fan, if I want to turn on the fan, I can tell the services, a turn on the fan. Turn on is a service identifier. If you see, we need to turn on. We need to perform on and off operation. What on and off function? It will tell the subfunction fan. If it is 03, it's a fan. Okay, I need to make a turn on the fan. So if you mention the some parameter like 2, so 2, if we consider, what we can what server will understand, okay, I need to turn on the fan or speed 2, then it will perform that particular task. So only few services it will support for this parameter. It's optional. So like for example, if you take turn on the light, so if I'm telling the server turn on the light, so I'll tell turn on the light with what speed. I can't mention any speed, right? Only light. In that light we can turn on, turn off. Only two functions we can do. So parameter, if I turn on the light with 2 degrees Celsius or something, like, it is invalid. It will not consider. It's meaningless, right? In that situation, parameter is optional. It's not applicable. So this is how client server in this uh, uh, format, request format, we can achieve a request of the uh, particular service from the server. Next, once processing is done, server should respond back to the client. So here, what will get? Response ID, request SID plus 40H. So here the small assignment, if people can just go and dig back why 40H is added after the service ID. So we'll discuss in further lectures, and do please comment on the comment section. So now response, we have to see, response will be the service identifier, subfunction or parameter ID is optional. So now server has processed something. After particular or completion of task, it should send the acknowledgement, and we need to get a response, that is positive response. Server, it will provide two types of responses. One is positive response if task is achieved or successfully completed. Else it's a negative response. We used to call as NRCs. If task is not completed, it will throw an NRC, and it will tell why. Based on the NRCs, like the negative response codes, we can come to know why task is not happened and what is the reason. So now we'll see positive response. Positive response will be having request SID plus 40, means we have sent 11 03 for soft reset. Now we'll 11 plus 40 51. So in response we'll get 51 03. This is a response. Any parameter is optional. Only I want a soft reset. I have sent a request 1103. In turn 5103 I am getting. So this is this format for doing a soft reset via diagnostic service request. Next, we have a negative response format. So negative response format is very important. So we have to get to know why negative response thrown by ECU and what was the main reasons. So if we see here, negative response format should be starting with 7F, followed by service identifier, followed by NRC type. Means you have sent a request for soft reset, the 1103. If it is if it is something error, then If you see the NRC's negative response with proper reason, the format will be like this: 7FH service identifier NRC type. So for example, what I can do, instead of sending, for example, I have written here the request of ECU reset. See, reset in the microcontroller is two sub functions are there. One is a hard reset and soft reset. What I can do, I'll send a 1103 to reset to get a soft reset, and we saw the soft positive response 5103. In case, instead of sending 1103, if I send 110303, we supposed to send 2 bytes. One is the SID 11 and 03 is a sub function. Instead of sending 2 bytes, I am sending 03. Means 3. If the request is sent wrongly with the 3 bytes, how it server should respond? So server, it will see, it will check the response format, request format. It will see 3 bytes means 110303. It will not understand what is the meaning of this. It understood 11 is a SID and it has a some sub function 03, but 03 is invalid. So nowhere it's a meaningless. So for that, what server should respond back is NRC negative response like this: 7F followed by 11. We have sent 11, requested 11. So same with same service 11. And what was the reason? 13H. So here 13H is invalid length, invalid message length or something. So many NRCs are there. So we have NRCs invalid message length or subfunction not supported or request out of range. Many NRCs are there, and we will be discussing different NRCs in upcoming sessions with the particular UDS services. Here on overview level, how NRCs will get, because it is very important. If you get NRC only, we come to know what is exactly going on, what was wrong. So the moment 7FH 11 and 13 if I receive, or I come to know, so I have requested for 11. If you see 1103, I request for a service 11 and it's thrown NRC 13. So NRC 13 is the invalid message length. Then we need to check why is the invalid message length. We can go back and see our request format. It was wrong. So we can correct it and send back and to get a correct positive response. This is how it will work in UDS. Okay, I hope this is clear. And one more important aspect is suppress positive response. So we saw we have sent a request and we have received positive response. Also we have received negative response. So in some cases, what will happen? Many servers will be connected, and if you have requested many requests, many requests will be sent in a car where in a functional addressing mode. Many requests will be going and response will be coming. So in some situations, we need only to perform the task, but we no need of any positive response. So if you requested some task to perform by ECU, and you don't want a response, only you want the task to be done. So it will be helpful when to reduce the bus loading. So I want a task done, but for that particular task, I don't need any response. So for that one mechanism we have suppress positive response. So suppress positive response only applicable whenever subfunction supported for that particular service. So here service identifier followed by subfunction parameter and parameter. This is optional. So valid for all services with subfunction, and negative response will be sent independent of this suppress positive response. Here if you see carefully, we are suppressing only positive response and not negative response. So UDS specification will not allow us suppressing a negative response, because we need a negative response. We have to know, right, what is happening. So we get to know what was went wrong, what's wrong in the system. For that we need a negative codes. From that only we get to know what is wrong. So we can't suppress the negative. Only positive response we can suppress. For that, if you subfunction, if you say total 8 bits, 1 byte of subfunction will be there. So 0 to 7, If you make a seventh bit 1, then you will not receive, it will suppress the post response. You will send a request. Job will be done, but you will not receive any positive response. Okay. So we'll be seeing these positive response in further detail in other UDS services. In overview level, I have given how suppressed positive response will be there. So here only seventh bit you have to make 1. Okay. For example, I'm sending service identifier something service identifier followed by subfunction 00. Suppose 00 is some subfunction and I don't have any parameter. So what I'll do only service identifier followed by 00 subfunction. So I'll send a request and I'll receive the response. If I want to suppress the positive response, what I have to do? Seventh bit will be set to 1. Means 100000000 means 80 I have to send. Service identifier subfunction 80 parameter not applicable. If I send this service identifier and subfunction 80, then that particular job will be done, but I will not receive any positive response. Instead of 80, I'll make a reset back to 0, and if you send 00, the job will be done and you will receive a positive response. If you make 1, it will take as a suppressed positive response. I hope this is clear. If not, please go back and see the video again. And we have some acronyms which is very useful, and we will be using these acronyms in day-to-day life in automotive diagnostic and automotive field. So first SID, the service identifier. That is what we discussed. SID is nothing but service identifier 11 issue reset. We were using SID 11. That is nothing but service identifier. And DTC, diagnostic double code. So each fault will be assigned some DTCs, diagnostic double codes. So we'll be discussing further classes, but DTC is nothing but diagnostic double code. PID is a parameter identifier. DPID, dynamic periodic identifier. DID, data identifier. So DID is nothing but a data identifier. Many diagnostics implementation will come across DIDs. Suppose DID has a 2 byte in a length, and we'll be using that DID to request any information from the ECU or to write some information into ECU. For that purpose, we'll be using the DID. We'll be seeing the detailed regarding this DID in further sessions where we are discussing different UDS services. P codes is nothing but a